Right. So welcome to Data-Driven AEC. I've look at like your work on LinkedIn, and it's like a really interesting profile, and that's why I reached out to you, Andry, to see if you would be interested to share your experience in digitalization in AEC, and yeah.
Yeah, that would be wonderful. So I don't know how you perform the interview, or where do you want us to start?
Yeah, so I will just ask some questions. Like you can just reply whatever is in your mind. So the first one is, what is your quick elevator pitch? So what are you working on in one sentence?
Sorry, what I am looking on the.
What are you working on in one sentence?
Yeah, so I work especially in robotization, robotization in construction. So if you want to sum up a little bit what I do is I want to transpose what you can see in Industry 4.0 into construction, but not just construction, seeing the bigger picture and seeing the construction as construction 4.0, and trying to leverage robotization in the construction industry.
Okay.
So that's my main focus of work. So, but this work encapsulates a lot of stuff. So you have, like, when you look at the technology that you can find in Industry 4.0, construction industry lack a lot of this technology. When you you can see it in the in all of the article published in the last decade on AEC and thinking about that. So we lack digitalization, we lack new process of fabrication, we lack security, we lack productivity. So when you look at some of the evolution of manufacturing industry, for example, manufacturing industry, they have almost doubled their productivity since the last decade.
Yeah, exactly.
Construction industry, they stay still, and they didn't change any process. What drives me in the field was I look at when I was in my after my engineering school, I did a specialization in structure and geomaterials before doing my PhD. And I was looking at two construction sites, one from 1967, I think, and another one from 2018. And what struck me was that it was the same process. It kind of, there was nothing that changed between these almost 50 years. So I was thinking, what did we do wrong on that part in the construction industry? Because when you look at manufacturing industry, for example, if you visit some textile industry or car industry is a really good example. When you, because I had the chance to visit Toyota industry, Toyota car manufacturing in France, near near Centralville, where I did my PhD, and I was struck by how amazing their work is. The work is lean, so you have like a production line with new technology, with robot and everything. So the safety of the people, it was amazing. But when you go to a construction site, it's
still very dangerous.
Yeah, it's
like so
you
primitive.
have too much at the same time. There is no safety. Things are moving around. When you are looking for a tool, for example, the tool is not at one place. Everyone has his portative tool. It's not lean.
Yeah.
Yeah, so I was thinking, what can I bring in this messy kind of construction site to get something like I don't know, an order, and to give a sense of safety to the people working there, because when you look at statistics too, people in construction industry has a lot more problem when they finish their work. For example, when they get 50, they have musculoskeletal trouble. They have problem with their back and everything. So that was my main thinking when I entered the AEC industry.
Yeah.
And yeah.
So you started from like a structural engineering kind of.
Yeah. My background, I have. I am an engineer in general civil engineer.
Yeah.
So I am a general civil engineer. So I have like a good vision of almost all the work that you can do in civil engineer, from road to construction site, buildings and bridge or anything related to construction. So, but after my engineering school, I had this feeling that I wanted to go deeper into how all of this structure work. So I found a courses in Lille that was working on structure and geomaterials. So I wanted to work on new materials too. Something like why don't we use earth, for example, a little more, something like that. So I did 1 year of a master thesis there, and after that I had the opportunity to pursue a PhD, and at when I get my internship was about additive manufacturing and construction. And trying to use ecological materials. So I had another intern the year before that already worked on formulating printable concrete.
Okay, but I wonder, like, how do you? Apply these technologies in reality? Are you always in a research position, or they are actually also connected to the reality?
Yeah, when I finish my PhD, I get into a company called Batiprint 3D, Batiprint 3D. So my aim when I started with the company was to transpose what I did in research into the real field. So the first year when I was in Batiprint, we constructed a house located in Angers, in France. It's an ecological house. That is, it's already open. You have everything there. It's finished. I can show you perhaps the house concept. Sorry. The house is called Concept Empreinte, and it was built in 2021.
Mm-hmm.
And it's already standing. Let me share my screen if it's possible. Yeah, share. Got it. So this is the house that we built with an additive manufacturing process. What's different with this one from the other that you can see is that the main product that we use is not concrete here or mortar. We use insulation material called polyurethane, and we use like a formwork. So we printed the formwork. All of this, if you can see the curves on the house and everything. Yeah. So I don't know if you see a little bit of the video, but you can see that you have a formwork from the foundation to the first. Yeah.
Cool. So you designed the formwork first, and then
yes.
robot to
Then
manufacture.
you add the structural concrete into the formwork.
Okay.
So you have a two-in-one solution. You have the insulation and the structure in the wall at the same time. So this was a real-life test that we did, and where I participated. I was the main engineer for Batiprint, and we had a lot of people working with us. So we tried to implement from design to fabrication. So we had a BIM manager there, that the architect and the BIM manager that worked everything with us, and we took all of the material from the BIM into our robotic part, and then brought it to the construction field, as you can see here. Yeah, that was one of the biggest achievement that we did on with the company.
Cool. Wow.
Yeah.
Is it something also like can be applicable elsewhere? Like this is just the methodology you tested, right? Like you can actually build similar houses somewhere else.
Yeah, it's a technology that you can use almost everywhere. So the thinking was providing a easier and easier construction and a rapid construction. So here normally in 21 days you can have all the wall printed. And the rest of the time you will have to do the finished job for the house.
Nice.
And the idea was to bring that into the construction industry, and bringing the fact that you will have the productivity, and the fact that you are using the chain from digitalization to the fabrication. You will have a better understanding of how the flow of your work will be, and you can predict when you will put things. So the idea was to have a complete flow of work from the concept to the fabrication. And we tried to bring it to the construction industry, but now it's the economic model of additive manufacturing is very difficult. So in the world, I think you have 2 or 3 companies that have successfully implemented a good economical model. So you have Cobod. I don't know if you know of them. Cobod, they are Danish. So they have a really good machine. And they implemented a lot of stuff that is working well. The economic model is good, and they have already reached their ROE, I think. And the concept is to have a model-like configurator in the website. So you can configure your house, what you want to have, and purchase the house, and they bring the machinery and print it. You have other concepts, for example, from X3 in France. X3, they are not specialized in building entire house, but they are specialized in what we call a specific part of the house. For example, if you have like a beam that you want to add some style in it, or you want to add biomimicry, you want to add like a tree style beam. X3 is specialized in giving those services. So they bring services for really specialized part of the building, like beam or something like decorative part that you cannot do with traditional fabrication methods. And you have free form from X3. X3 can do almost everything that you have in mind. It's really great for architects, but they don't do all of the building part.
Okay.
Yeah.
I see.
The main reason that additive manufacturing in construction now is not more advanced is the fact that the economical model is still lagging behind, and you have the code compliance.
Yeah.
Because each country, they have their code. For example, in Europe, you have to respect Eurocode. I think in America or English-speaking country, most of the time you have another one. It's BU or ITM. And the fact you have all of this code compliance, it's really difficult to bring new technology into the construction because the codes are really strict. And the fact that the new technology coming, they don't, it's not like the traditional way of fabrication. And the code does not take into account the new process. That is the second part, because, for example, here in France, it's really difficult to bring new technology into the construction because you have a lot of steps. Like in medical part, for example, when you need to go through FDA, in France, you need to go through an institution called CSTB. CSTB, depending on what kind of process you bring into the construction, you have to justify a lot of points in order to bring it. Yeah. So the house, for example, the house that I showed you, it had a temporary construction acceptation. So it was just for the one construction field. You cannot generalize it yet. So each time you have, in order to generalize, you have to construct at least 3 or 4 type of different house with the same process. And then when they look at it and they say that you almost tried every little it's not problem, but every little specification that you can find in construction in those different kind of construction site, you can start a generalization, but the generalization will stand just for 5 to 10 years. And after that, you have to renew it, and you need at least 50 to 20 years to bring new process into the existing code. And this is a lot of work.
Wow, it's almost like a medical thing.
Yeah, and because in France, it's really important, because when you look at the Maslow pyramid, for example, houses are a primary need, because with houses you have the safety. And here in France, when you bring people into a house, the safety is the main concern. So if the process doesn't meet those safety and the durability concept, you cannot use the new process. Yeah, so it's a good thing, but at the same time, it's hindering the evolution of the construction industry.
Okay, that's very interesting. So you think the most difficult part of this is not actually designing the prototype or like how to work on it, it's more like bringing it into the market?
Yes, because you see, when you look at the company or even the engineer working on it or the researcher working on the 3D printing, in the 5 last year, I think the evolution in the process itself is astonishing. They have made, you can see that there are a lot of new buildings built with additive manufacturing. The research on durability is really great. The productivity is great. And the engineering solution is there. So not the engineering part, the problem, it's more of how you can convince that this part, this engineering part, this process part can meet the requirement of the code that you have.
Okay.
Yeah. Because most of the time you can see when you give a problem to an engineer, he will find a solution for it.
Okay.
But depending on what you have next, it's a little bit more difficult to bring it to life.
Okay, that's very cool. And I also wanted to know, like, how are you actually are you using any like data or AI stuff in your process, or?
Yes. So data is, I want to say it's the main component of the work too, because when you at construction, most of the time people see walls, buildings, and everything, but you have to look at it closely, because the first step is the client, for example, the client that would go to the architect
Yeah.
It's a first input. So the first input is already a data. For example, the bird that he wants, the kind of house that he wants, and everything that he wants. So the architect will have to translate this, the view that the client have in mind into something, into a rendering. And from that part, this data of walls and beams and everything will have to transit through a structural engineer, a lot of engineer. The AEC, with the help of BIM, they try to collaborate in one structure and have like it's a lot of data passing through there. So that is the first part in the design phase.
Yeah.
And you have, from this design phase, you have the construction phase. In order to have this construction phase working great, you have to pass the first data from this design into the construction. But people don't see that there is data transiting. Look at it outside of the construction system. And this data, for example, on my part, when we get the design to the construction phase, I need, for example, the wall, the topological data, the building data. For example, where is the wall, where is the door, where is every little thing in the wall to construct it. And when I am doing the construction phase, for example, in additive manufacturing, it's really interesting because you can imagine that, for example, when I lay the first layer, it's like I'm laying an infinite brick, but continuously. When I do that, my machine, the machine that I use sensor with it in order to track is the layer that I'm putting down, respect, for example, the height, the weight, and everything related to the wall. And this data, when you look at the machine test, the machine can predict, for example, because concrete or anything material that you put into the process, it's a live material. It doesn't feel. So when you work with robotics and materials at the same time, you have to find a synergy between the machinery, the materials, and the environment. So, for example, if you have dry weather, for example, your formulation will not be the same as if it's really humid weather, or there is a lot of wind. So, in our company, we implemented a kind of model that can predict in time how it can manage to change some, for example, the temperature of the formulation in order to have the same product at the end, even if you have different environments.
Ah, that's a very good use case.
This is just this is the first step, because this is just a predictive model. It's kind of just machine learning.
Yeah.
But there are other work. For example, in our company, we work on agent too.
Mm-hmm.
But the agent will work way before construction phase. For example, you have 5 or 6 machines puzzle, and you have different kind of construction field with different complexity. So the agent will have to analyze that.
Yeah.
And he will dispatch the machine. For example, with this complexity, you need 2 kind of machine with different kind of end effector. So he will tell you everything. He will try to give you a planning, and you can accept or not, depending on the expertise of the engineer working on the numerical digitalization part. It's a SaaS, like you can have. It's a software as a service that we brought in our company that can help the engineer. But what is really important, the AI doesn't work alone. The AI, you need the AI to help you.
Yeah.
And you still need an expert who validate or to accept what he proposed or add some change in it. So yes, we work a lot on data.
Yeah.
But most of the time, when you are from an individual, when you look at the machine, you don't obviously see the data, but there is a lot of work on it. Yeah, so we can have from simple machine learning algorithm to predict change on materials. You can have a more complex deep learning algorithm. For example, for our machine, we used it on vision, because most of the time you have the beam, have the rendering and the model, but when you go to the construction side, there can be difference. So we need vision in order to see if we need to correct and have a digital twin of what we are doing. So in our machine, we have a vision camera and some laser LiDAR to map locally what the robot is seeing, and if what he's seeing is similar to what we modelized earlier. And if there is difference, he can correct it locally and update what you have in your numerical model.
Cool.
With this, you need a kind of deep learning algorithm to. You have to have a lot of previous imagery or something like that, and give the algorithm a way to understand what he is seeing. For example, in our case, we had to use that in the window. There are a lot of different type of window, and most of the time, the reference that you have in the beam is different from the reference that you see in real life, and the dimension can be different because the house they change it in between, and you didn't have the update made earlier. So this comes especially in renovation. Yeah.
I see.
So you have like I said, machine learning, deep learning. You have the use of LLM too.
Yeah.
The use of LLM is most of the time you can see it in the inspection part. For example, you have two kind of part where the inspection, you take picture, to ask it to analyze the picture, depending on a model that you already put in it, and he can tell you if there is thing to correct in it or not.
Okay, nice. Yeah, I think that's really insightful. And we're almost like to the end. I still want to ask, like, what do you plan to do next, and where we can follow your work?
Yeah. So now I am. Our company, we had, like I told you, the problem now is the economical model. So I started with my company. It was a startup, and we didn't make it into the how can we say, we needed funds, and we didn't make it until that.
Oh.
So now now I am looking to another challenge, but it will still be on AEC.
Okay.
So I will always be working on this construction industry, but trying to leverage the new technology that we can find in other industry into the construction industry. And hopefully I will be working, for now I have taken a research work. It's not a permanent work, but I am working a bit on LLM with a lab called GEM, but the idea is to have a certain corpus of article specialized in one domain, define the ontology of this domain, and ask an LLM where do we have to go next. So this is a work that I'm doing now, and the second work that I'm doing is on optimization of the comfort and temperature in a building.
Okay.
Yeah, so this is another work, but it's mainly on machine learning. It's a predictive part. And the last thing that I do, but it's more of a personal work, it's about robot.
Okay.
How can what kind of robot can I bring now into the construction? Because there are a lot of robots that you can see. And my main focus of work when I did my PhD was working on system of system. You can see it in the defense industry. For example, if you have 5 kind of airplane, attacker plane, they are working together for a main objective. So the idea for me was, how can I have 3 or 4 different companies using different kind of robots, but for the same goal in the construction side?
Wow, that's a very difficult problem, I guess.
Yeah, this is my main research, but that's what I want to do next, depending on what kind of company that I will I will have.
Okay, so you're now working on a startup, but you don't know yet what are you building. So you're not like working for anybody else right now. Like you're just focusing on this.
Yeah, I'm in between job, but I am working most of the time in a lab near the university that I live, and I'm working with a university professor that already worked with me when I was in Batik 3D.
Cool.
Yeah, so we continued a little bit our work, and we wanted to explore new kind of stuff, because even if I work a lot on the hardware part, I think the rising of AI, you need to see where it's going, and you need to understand how it is working, because the machine learning part, I think a lot of people and a lot of applications are already there. Machine learning, deep learning, everything related to that, it's already well established. But for now, agent and LLM, we are using it on some personal matter, for example, but in construction, it's still a little bit behind. Even if there are a lot of researchers that are already working on it, but it's not the same as machine learning, where you already have a lot of stuff implemented, and that you can see, for example, in the automation industry, Siemens have already add some library that can do predictive models in their software. This is already implemented, yeah.
Nice, cool. Yeah. Wow, that's very exciting. And do you have any advice for people who are following your path of digitalization in AEC? What do you think you would suggest?
Yeah, the advice would be you have to continue, because I know that when you enter AEC, the first year, most of the time, it's difficult in kind of finding something that matters, but it's not the people, it's not you, it's the way of thinking of the company, that they are still way back. I think construction industry, they are late, I think for 50 years. They are late of 50 years of age. And you have to believe that when the time will come that they will understand that they have to modernize or die. Because it's what I like this quote from Mark Farmer. He was an English, I don't know if he is an entrepreneur. I saw him at a conference 5 years, 10 years back, and the British government asked him to do a state of the construction industry in England. So the title of the report that he put was "Modernize or Die." So the construction industry, at one time, they will have to modernize, or you will have Samsung or Orange, or I don't know, another kind of technological company that will enter the construction industry, and they will change everything. So all of the older one, like I don't know, Vinci, Bouygues, or Skanska, or all of the old one will be put to rest, it's like Nokia when the smartphone came. So at one time Nokia was on the top of the world, and when you look back, you see iPhone came, Samsung came, and Nokia, Motorola, they didn't embrace the new technology that was coming. So that's why they lag behind.
That's
so I
very
think
interesting.
For the people that are coming, continue to believe on what you are working on AEC, and I'm confident that in 10 years or 20 years time, construction industry will embrace this new technology.
Nice. Wow, that's so cool. I feel so encouraged after hearing this.
So, thank you very much.
Yeah, thank you. And I will just let you know when I have to do the editing, and let you see it, and then we will publish it somewhere maybe in the next 2 months.
Yeah, and for example, if you have other question that you need to answer in writing, you can send it to me, and I try to get back to you and bring you some of the things that I have in mind.
Yeah, awesome. Yeah. And you can also send me like your personal website or like some link where we can find you, those kind of things. Yeah, okay, no problem. Okay, great. Right, it was really great to talk with you. It's so like very calming and really cool. Thank you. Yeah, thank you very much, Rini. So I hope next time. Yeah, see you next time. Bye. See you.